Hi everybody, here's the video for section 11.5 and its associated homework, which is number 42. So please have the following in front of you as you go through this video. Your notes for 11.5, obviously this computer with the video. Homework number 42, and very important for this video, is the theorem sheet. So if you don't have it in front of you, please pause the video, go get it, and have it with you, because we'll talk about it later. And then also your vocabulary sheet. So the week of April 30th to May 4th is focused on sections 11.5 to 11.6. Some people may be ahead of that, and that's fine. So associated with 11.5 and 11.6 is 42, homework's 42, 43, 44, 45 is a review, just like the previous 2 weeks. So by the 4th of May, you should be ready to turn in your notes for 11.5, 11.6, and these three homeworks, 42, 43, and 44. And then Friday will also be the last day to take the 11.4, 11.5 quiz, which hopefully you'll all be ready for by then. Okay. So we start out with something that you hopefully all know already, but we just want to review it quickly. So remember that this whole chapter is about measuring length and area of different shapes. And 11.4 concentrated on circles, and so does 11.5. So 11.5 is about how to measure the areas of circles and sectors. So remember in previous chapter we talked about the circumference of circles, okay, the length of a line drawn around that circle. And then we talked about the arc length, so the measure of the length of a piece of that circumference. Okay, so now we're going to talk about the areas of circles. So if we have a circle, the area is all that area inside, okay, and a sector is a part of that circle, a piece of the pie. Okay, so just like an arc length was a piece of the circumference, okay, the sector is a piece of the whole of the area of the circle. So hopefully you remember from middle school that the area inside the circle, this yellow part, is equal to pi r squared. Remember, the circumference was equal to pi d, or also 2 pi r, whichever one is most convenient to use at the time. So make sure you get those squared away. What means what? Okay, the difference between a circumference and an area, and an arc length and a sector. And we'll talk a little bit more about that later. Papers here. Okay. Okay, so just a little practice here. So here we have a circle, and we're given that the radius is equal to 5. So r equals 5, and we're going to find the circumference. So remember, there's two ways to find circumference. The first way is 2 pi r. Okay, and remember the circumference is the distance around the circle. Okay, that little line in green. So 2 pi r is equal to 2 pi, and we're given that r equals 5 times 5. So combining like terms, 2 times 5 is 10 pi. And you can see if r is equal to 5, then the diameter, which is this whole line, is equal to 10, which is 2 times 5. Okay, so the other way to calculate the circumference is pi d, and we know d is equal to 10, so we have 10 pi. And it's kind of weird that when we talk about these formulas, we put the pi kind of in the middle or in the front of the r. But when we use numbers with pi always comes at the end. So you have 10 pi, 20 pi, 30 pi, whatever. Okay. Whereas we talk about 2 pi r or pi d. And it's just a little convention you just need to get used to. So mathematicians have their quirks too. So here's area, and we're reminded that our formula for area is pi r squared. And remember that area, let's take away circumference. Our area is all this yellow part inside. Okay, and that's equal to pi r squared, which in our case is pi times 5 squared. And 5 times 5 is 25, so we have the area is equal to 25 pi. Okay, and remember, right now we're just treating pi as a number, but we'll talk more about how to what number we use for pi in just a couple minutes. Okay, so now we know the area of a circle. Now we want to figure out the area of a sector of a circle. So remember, a sector is a piece of the pie. How big is that piece of pie that you're eating? Okay, so the sector of a circle, here's your definition, is the region bounded by 2 radii of the circle. Okay, here's my radii. Here's 1, 2, and their arc. Okay, so just like a piece of apple pie, you've got 2 straight lines if you cut it nicely, and then you've got this rounded part along the edge of the pie pan. Okay, and in this diagram, sector APB is bounded by line AP and line PB and arc AB. Okay. So now we can find the area of a sector. We already know how to find the area of a circle, so we want to be able to find the area of a piece of the circle, or the sector. So the areas for sectors use ratios. And remember, to find the arc length of a piece of an arc, we also used a ratio, and we'll review that in a second. So in words, what we do to find the area of a sector is the area of this sector over, divided by, the area of a circle so that's the area of the piece of the circle divided by the area of the whole circle, and I didn't do a good job of spelling circle. Okay, is the same as or equal to the measure of the arc of the piece. So I'll say piece of arc over, okay, the measure of the circle, the whole circle. So we shorten this, we start to use our numbers, and so we have the area of the sector over the area of a circle, which we know is pi r squared, is equal to the measure of an arc, which in this case would be the measure of AB, over the measure of the whole circle, which is, as we know, 360 degrees. Okay, so we always put the part over the whole. So the part, which is the sector over the whole circle area, is equivalent to the measure of the length of an arc divided by 360 degrees, the part divided by the whole. Okay, so let's take a step. Well, let's give it a shot and see what we can learn from doing some practice. So, what should we do first? I think we're going to do that. Okay, so we're looking for the area of circle D, and so that's the whole area. Excuse me. Okay, and we know our formula for area is equal to pi r squared. Okay, so number one, so our area is going to be equal to pi, and we're given our radius, which is 14 feet, so that's 14 squared, is equal to 196 pi. And pretty easy. Okay, so let's look at the area of this red sector. So I'm going to erase some of these other marks so we don't get confused. Okay, so we're looking at the area of the red sector. Looks kind of pinky orangey, but okay. So the red sector, we need to use our area of a sector theorem, which again says the sector area over the area of the circle is equal to the measure of the arc that we're interested in. Again, the piece of the circle, measure of the arc, in this case it's EF, divided by the measure of the circle. Okay, so let's fill in the areas. So our sector area we don't know, and I'm just going to abbreviate that to SA. Okay, the circle area we already know, okay, is equal to 196 pi. So we already calculated that. Is equal to the measure of arc EF, and since the this angle is at the middle of the circle by the center point, we know that this arc is equal to this angle here. So the measure of the arc is 120 degrees, and the measure of the entire circle is 360 degrees. So what do we do now? As we always do with these kind of problems, we do a cross multiplication. So we have SA times 120 is equal to 196 pi times 360. So this is equal to, written down, 23,520 pi. Okay, and now we're going to divide both sides. What did I do wrong? It's SA times 360. Set up my equation wrong. It's equal to 196 times 120. Okay, sorry about that. So we're going to divide both sides by 360, and we get SA is equal to 65.33 pi. Okay, and if I calculate with pi, this ends up to 205.15 feet squared. So that's our answer. And our area of our rectangle is 205.15 feet squared. Okay, so that's how to find the area of that piece of the pie. Okay. So now we need to find the area of the blue sector. So I'm going to erase all this. Let's see, except I'm not going to erase this area because we'll need it. increase the size of my eraser so go faster, but that's okay. Okay, so let's go to blue. So it's just a little bit, makes a difference. Okay, so we're going to set up use the same formula again. So the area of sector over the area of the entire circle is equal to the measure of the arc in question, okay, over the measure of the circle, the entire circle, the part over the whole. So the area of the sector is what we're looking for, so we don't know that yet. Okay, the area of the circle we know from our calculation in number 1 is 196 pi. What's that point doing there? Okay. Sector is equal to the measure of the arc. Now, we know this measure, FE, was equal to 120 degrees, but we're not interested in that anymore. We're interested in this arc. So what do? So hopefully you remember from the previous chapters, we have the whole is 360, so we can take away 120. And what's left is 240 degrees. Okay, so this arc length is this arc measure is 240 degrees. So equals to 240, and we divide that by the measure of the whole circle, which is 360. So again, we do our cross multiply, cross, and we shorten SA times 360 is equal to 240 times 196 pi. Okay, so 240 times 196 pi is 47,040 pi. We're going to divide both sides by 360, and so we're going to end up with 130.67 pi, which, if we work out the pi, is going to be 410.3 feet squared. There's my answer. So 410.3 feet squared. So you notice in these problems that a lot of times you're not ending up with whole numbers. You're ending up with decimals. And some of you are getting kind of anxious about that. Don't worry about it. That's where we are, and you're practicing using your decimals now in order to get ready for Algebra 2. So don't panic if you get a decimal. It does not necessarily mean that it's wrong. Okay, let's talk about pi. So if you go to your phone and you plug in pi, okay, here's the, oops, crud. Okay, yeah, plug in pi, okay. This is what you get. You get this 3.1415926, blah, 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 okay. And actually the number goes on forever. So what we're going to do, and what most people do actually, is we are going to use the abbreviation that pi is equal to 3.14. So in your calculations, please use pi equals 3.14. As you can see, we've rounded it, right, into the hundredths place. So if I look here, there's a thousandths, there's a 10,000ths. So the 10,000ths is a 5, which when I round means I have to round the next number up. So that would give me 148.1412. But 2 is less than 5. So when I round it again, I don't touch that number, and it just stays at 3.14. Okay, so please memorize that. Pi equal 3.14. Now, when you get into Algebra 2, potentially, or classes higher than that, and definitely in calculus, okay, you're going to want to use the whole number, or at least a large part of it, and at least 4 digits, okay, when you do your calculations, but that's later on. So for now, please just use pi is equal to 3.14. Okay, all the answer keys will be geared to using pi equal 3.14. Okay, I just wanted to clear that up. So now, let's look at something else here. We've thrown a lot of information at you about circles. And what I'd like to do is try to help you organize that for yourself. And here's where you use your theorem sheet. So please get out your theorem sheet. Don't try to listen to this without it. Okay, so if you need to pause to get your theorem sheet, please go ahead and do that. Okay, so now I'm going to assume that you have your theorem sheet. So all these 4 theorems, or 3 theorems and a corollary, these are all about circles. Okay, not about anything else, just circles. Okay, and so let's look at these in general. So if we split them in half, okay, theorem 11.8 and the arc length corollary, these all have to do with length. Okay, the circumference, which is the length around the circle, okay, and arc length, which is the length of an arc. Now, theorem 11.9 and theorem 11.10, actually I'm going to change colors. Let's do purple. Okay, these all have to do with area. Okay, so you've got 2 theorems for length and 2 theorems for area. Now we can further divide these. We can divide them this way. And here we see that the 2 theorems on the top, those talk about the whole, okay, the whole circumference of a circle, the area of a whole circle. Okay, so these are your wholes. Down here are your parts. So here's the part of an arc, the arc length corollary. Theorem 11.10 is the area of a sector, which is part of a circle. Okay, so if you have a question that asks for an arc length, you're going to go, oh, okay, so I'm looking for length and I'm looking for the part, and voila, here's my arc length corollary. Okay, and then the same thing with a sector. If you're asked for the area of a sector, you're going to say, okay, I'm going to go to the area side of my theorems, okay, and then I'm going to choose the part because I'm looking for the part of a circle. Also, okay, please notice in these, if you haven't put notes on your notes like you should be, okay, these are not complete as they're written. Okay, so look at the arc length corollary, and they've left some missing parts here for you to fill in. So the arc length of arc AB is over the circumference, which we know is 2 pi r, and that's equal to the measure of arc AB over the measure of the entire circle, which is 360 degrees. Okay, and you can move some of those around, simplify a little bit, and you have the measure of arc AB over 360 is equal to 2 pi r. Okay. Now up here on the right, you have the area of a circle you need to fill in. Area equals pi r squared. Okay. And then the area of a sector. Okay, the formula, area of a sector over the area of the whole circle, which is pi r squared, is equal to the measure of the arc over 360. Okay, and that can also be written the area of the sector is equal to measure of AB over 360 times pi r squared. And, oops, and I made a mistake over here. Okay, should be at times. Okay. So make sure you make those notes, or else you're going to get into the test and you go, but wait a minute, I don't know what the area of a circle is, because you didn't put it in your theorem sheet. Okay. So now we're going to put this all together. And here we have the whole enchilada. So this kind of problem, it asks you to fully analyze a circle. And very easily on a quiz, I could ask you one single problem and it would look just like this. Okay? I could give you one circle and ask you to completely analyze it for me. Okay? So, oops. We're at the end of the slideshow. And these take a while, okay? So don't think that you're going to finish this in about 5 minutes, because it's going to take a little bit longer than that to do. So, but as usual, we divide and conquer. So let's first look at what we're given. So the area of circle M, my area is given, and it's 260.67 inches. Why are you doing this to me? 260.67 inches squared. Okay, the area of sector KML. Okay, there's my sector. There's my two radiuses and my arc. So my area of this sector is equal to 42 square inches. That's a 4, not a 9. Okay? So we're given that. So let's look at number 20. Okay, the radius of circle M. So you look at your theorem sheet and go, okay, I don't have any theorems that tell me how to find the radius. But you need to look at what you do know. So you do know the area. And you also know the formula for the area is pi r squared. So area is equal to pi r squared. Okay, I know my area is 260.67 is equal to pi times r squared. So we're going to divide both sides by pi. Those two cancel, and here we're going to substitute 3.14 for pi, and we are going to get 83.02 is equal to r squared. Okay, and how do we get rid of the squared? Okay, we take the square root of both sides. Square root of 83.02 is 9.11, more or less. And square root of r squared is r. So we know our radius here is 9.11. Okay, and this one is also 9.11 because all radiuses are equal. So we're going to write up here r equals 9.11. Okay, so we've taken our first step. I'm going to erase that. Again, if you need it, go back and copy it. Okay, so the circumference of M. Let's look at 21. So, circumference of M, we know the formula, C equals 2 pi r, and in this case it's easier to use the formula C equals 2 pi r instead of pi d because we have r. So it's just a little bit easier. So that's going to be equal to 2 pi times 9.11. It's going to be equal to 18.22 pi, or substituting 3.14 for pi 18.22 times 3.15, 3.14 is equal to 57.21, more or less. Okay, so our circumference, our length around the circle, is 57.21 inches. Yeah, I think these are all inches. Yeah. Okay, so 2 down, 4 to go. Now, let's look at number 22. Okay. So we're looking at the measure of arc KL. So remember, the measure is the number of degrees. Okay, it's not the length, it's the measure of that arc. So we know that the area of a sector, so we need to find a formula that takes the stuff we know and then figures out the measure of the KL. Okay, so let's look at the area of a sector because KL is actually part of a sector. So let's look at that. So we have the area of the sector over the area of the circle, the part over the whole, is equal to the measure of the arc, which is KL, over the measure of the whole circle. Okay, so area sector, or sector area, is what we're looking for. Oh no, actually we've got the area sector. We know it's 42. So we know it's 42 over the area of the circle is 260.67 is equal to the measure of our KL, which is what we're looking for, over the measure of the circle is 360. Okay, we take that and we do our cross multiplication. So 42 times 360 is equal to 260.67 times the measure of our KL. So 42 times 360 is 15,120 MKL. Okay, so 260.67 and measure KL. We're going to divide both sides by 260.67. Of course, those cancel. Okay. And miraculously, 15,120 divided by 206.67 is almost exactly 58. Okay, so the measure of arc KL is equal to 58. Remember, we're talking degrees here, so 58 degrees. So, let's look at number 23. Actually, I want to do 24 first, because I think it'd be easier, because then we can use that information. Okay, so let's look at number 24. Okay, we're looking for the length of arc KL, not the measure. Okay, remember in 22 we found the measure of KL, which is in degrees. Now we want to find the length of KL, okay, which is the length of this line right here, and that'll be in inches. So we look for our arc length corollary, which says that the length of KL over the circumference of the circle, okay, is equal to the measure of KL over the measure of the whole circle, which is 360. So we know our circumference from number 21 is 57.21. And we know our measure of KL is 58. So we cross multiply. 58 times 57.21 is going to be equal to 360 times the length of KL. Okay, and we work all that out. And we come up with the length is equal to 3,318.18 divided by 360 is equal to 9.22 inches. Okay. So I'm kind of shortcutting through some of these calculations just to make things go a little bit quicker. But if you have any questions, please ask me. Okay. Let's do number 23. So it's the perimeter of the blue region. And change colors for these because we want to look at things a little bit differently. So I'm looking at 3. So I'm going to erase all this stuff here to talk about the perimeter. So what does the perimeter mean in this context? Okay, perimeter, remember, is the fence around the figure. So the perimeter of the blue region is the length from here to here and all the way around here. Okay, so we need to add together a radius, and then the arc length, okay, of this KNL. KNL. Okay. So we know what our radiuses are, so that's not a problem. So we have to find the arc length of KNL. And how do we do that? So we can be a little bit tricky about it. So we know the hole, the circumference of the hole, which is basically the arc length of the whole circle, is equal to 57.21. That's from number 21. Okay. Now we can take away this little arc length of KL minus length of KL, okay, which we know is 9.22, and we're going to have the remainder, okay? We're going to have this arc of this remaining piece when we take the whole and we subtract the arc length of that sector, okay? And this is going to turn out to be 47.99. Okay, so that is our arc length. So now we have to go back to our plan, which was to add the 2 radii, which are 9.11. So we're going to 9.11 plus 9.11. Okay, now we have to add the arc length of this whole blue piece plus 47.99. Okay, and that's going to be equal to 66.21. So this is the length of the arc KNL. Oh, sorry. It is the perimeter. Got what we were looking for, perimeter of blue region. Remember, this is radius, the other straight part of the pie, plus the arc length, okay, the arc length of that whole blue piece. Okay, let's see, length of the blue arc. Okay, so perimeter of the blue region is 66.21. Okay. So now, our last problem is number 25. Okay, I'm going to erase scribbles. So now we're looking for the perimeter of the red region. So we're looking here at this piece of pie right here. What is the perimeter of that piece of the pie? So that ought to be pretty easy at this point. So we already know that from problem number 24 is that the length, the arc length of KL is 9.22 inches. That's why I did 24 first. So in order to find the perimeter of the piece of pie, we need our two radiuses. Remember, this is 9.11. So we're going to add those together, plus 9.22 inches for the arc. Okay, radius, arc. Okay, and that is going to equal to 27.44 inches. And there we go. So we've just completely analyzed a circle. It took us 6 steps, and it used all 4 theorems. So this could very easily look like a problem on the quiz that comes up on Friday. So you need to know how to do all these different calculations. Okay? So again, if you have any questions, let me know. And good luck on your homework.